Most students get this wrong. Two cars, X and Y, traveling in opposite direction along the same highway at uniform velocities 110 km/h. So X is traveling with 110 km/h and 90 km/h. So Y is traveling with 90 km/h. Respectively, pass each other at a certain point. Calculate the velocity of X relative to Y. So when two objects are traveling at opposite direction to the other, their relative velocity is simply going to be the sum of the individual velocities. So the relative velocity here is going to be 110 plus 90, and that's going to be 200 km/h. What is the density of a fuel? We're asked to find the density of the fuel. Of relative density, we are given relative density to be 0.72, and we are given density of water as 1000. Now you need to remember the relationship that says relative density equals the density of substance all over the density of water. So the substance in this case is this fuel. So relative density is 0.72, which equals density of substance, that's the density of fuel that we're looking for, all over the density of water, which is 1000. So I'm looking out for density of fuel, so I simply cross multiply. I have 1 times density of fuel to give me density of fuel equals 0.72 multiplied by 1000. The density of fuel is going to give me 0.72 multiplied by 1000 is going to give me 720 kg meter per meter cube. A body is projected horizontally from the top of a cliff 45 meters above the ground. So we are given the height, which is 45 meters above the ground. If the body lands at the distance 30 meters from the foot of the cliff, so the foot of the cliff is usually this way, the distance between the point of projection and where it lands, and that is range. So we are given range to be 30 meters. Calculate the speed of projection. So we're asked to find u, and we're given g to be equal to 10 meters per second square. We find the relationship of range, which is r equals u into the square root of 2h over g. Then we say 30 equals u into the square root of 2 multiplied by 45 all over 10. Then we have 30 to be equal to u into the square root of 90 over 10. And then we have 30 to be equal to u into the square root of 9. Square root of 9 is 3, so we have 30 to be equal to 3u. We're looking out for u, so we divide both sides by 3. And then we say u equals 30 divided by 3, which equals 10. Don't forget to put the unit of speed, which is meter per second. This formula is very important in projectile. You will need it later. A simple harmonic oscillator has a period of 0.02 seconds. So we're given the time to be 0.02 seconds and amplitude 0.25 meters. Calculate the speed in meter per second. So we're asked to find v. Now we have to recall that v equals omega a. Omega means angular velocity. And angular velocity can be broken down into 2 pi f. Then we put our a. But for what we are given, we are not given f, we are given t. But there's a relationship between f and t, and f equals 1 over t, which equals 1 over 0.02. 1 over 0.02 is going to give me 50 hertz. Now that I've known that, I can now return back to this formula. So I'll say V equals 2 pi multiplied by 50 multiplied by 0.25. Then I have V to be equal to 2 multiplied by 50 will give me 100. Then I have 100 multiplied by 0.25 to give me 25. Then I put my pi. So I have 25 pi. Comment yes if you got it. A moving body of mass 25 kg. So we are given the mass 25 kg undergoes a uniform retardation of 20 meters per second. So retardation is the opposite of acceleration. They have the same symbol. A is 20 meters per second. Calculate the magnitude of the retarding force. So I have to find the force. And we'll say F equals the product of mass and acceleration. F equals mass is 25 multiplied by acceleration is 20. So force equals 25 multiplied by 20 will give me 500. Don't forget to put the unit of force, which is Newton. A thermometer records 680 millimeter mercury. Because of that unit, millimeter mercury, I'm going to use P. At steam point, that's P100 is 680 millimeter mercury. And 440 millimeter mercury at ice point. Ice point is P0, which is 440 millimeter mercury. Calculate the temperature. I'm asked to find temperature at 380 millimeter mercury. That is P. 380 millimeter mercury. Then I proceed to saying T equals P minus P0 all over P100 minus P0 times 100. So T is going to be P is 380 minus P0 is 440 all over P100 is 680 minus P0 is 440 times 100. And T is going to be 380 minus 440 minus 60 all over 680 minus 440 will give me 240 times 100. So if I say minus 60 divide by 240 times 100, I'm going to be having my T to be minus 25 degrees Celsius. A certain wave has a speed of 20 meters per second. We are giving speed which is 20 meters per second. If the frequency of the wave is 0.2 hertz, so we are giving frequency 0.25 hertz. Calculate the distance between successive crests of the wave. Some of that simply asking you for the wavelength. That's our question. And waves are the relationship V equals F lambda. So let's substitute. I have 20 to be equal to 0.25 multiplied by lambda. Since I'm looking out for lambda, I simply divide both sides by 0.25, and I have wavelength to be equal to 20 divided by 0.25, and lambda is going to give me 20 divided by 0.25, and that's 80. The unit of wavelength is meters. It looks confusing, but it's easy to solve. A solid of mass 0.5 kg. So we're giving mass to be 0.5 kg. Initially at 50 degrees Celsius, so we're giving the first temperature, which is 50 degrees Celsius. Melt at 60 degrees Celsius, we're giving the final temperature 60 degrees Celsius. Calculate the quantity of heat required, so we have to find Q, and we're giving specific heat capacity to be 2.0 kilojoule per kilogram per Kelvin, and we're giving specific latent heat to be 1.0 kilojoule per kilogram per Kelvin. So the first mistake students will do is to use these two directly, because they will ignore this K that is here. Kilojoule simply means that you multiply these two by 1000, and that's going to give you 2000 joules per kilogram per Kelvin, and this one is going to be 1000 joules per kilogram per Kelvin. Now, since we are dealing with both specific heat capacity and latent heat, our Q is going to be the addition of your specific heat capacity and your latent heat. So that's going to give us 0.5 multiplied by 2000 multiplied by 60 minus 15 plus 0.5 multiplied by 1000. 0.5 multiplied by 2000 is going to give me 1000 multiplied by 60 minus 50 is going to give me 10. So I'm going to have 10,000 here plus 0.5 multiplied by 1000 is going to give me 500. So 10,000 plus 500 is going to give me 10,500. Don't forget to put the unit of quantity of charge or quantity of heat, which is joules. Most students will get this wrong, and it is because of a little mistake. An electric drill rated 400 watts, we are giving power to be 400 watts, is used to drill a hole in a copper of mass 400 grams in 20 seconds. So we are giving time. Calculate the rise in temperature. We have asked to find the temperature change if all the heat is absorbed by the copper, and we are giving specific heat capacity to be 400 joules per kilogram per Kelvin. Now we are going to use the relationship Q equals MC change in theta. But we are not given Q, so we'll break it down and it becomes IVT equals MC change in theta. We're also not given IV, but we're given power, and remember that power equals IV, so we'll say PT equals MC change in theta. From here we can substitute to the formula. But where most students will make mistake is the fact that this mass is measured in grams and this specific capacity is measured in kilograms. Whenever you are dealing with it, the units in the specific capacity and the mass must be the same. So since we have kilograms here, we have to convert this to kilogram by simply dividing it by 1000. So we're going to have 0.4 kg. If you have done that, then you can solve this question. Let's substitute into the formula. We have 400 multiplied by 20 to be equal to 0.4 multiplied by 400 multiplied by change in theta. 400 times 20 will give me 8000. Then 0.4 multiplied by 40 will give me 160 multiplied by change in theta. Since I'm looking out for change in theta, and I simply divide both sides by 160. Change in theta is going to be 8000 divided by 160, and that's going to give me 50 degrees Celsius. If you got it, comment OK. In this diagram, we are given 3 resistors. 2 is connected in parallel while 1 is in series. So the first thing we need to do is to solve for the 2 in parallel. So we start with that. We say for parallel connection, we take the reciprocal. So 1 over R total equals 1 over 6 plus 1 over 4. These are the 2 parallel connections. So 1 over R total is going to be, then we find the LCM. The LCM of 6 and 4 is 12. 12 divided by 6 will give me 2. I'll multiply that 2 by 1, that will give me 2. Then 12 divided by 4 is going to give me 3. I'll multiply that 3 by 1 to give me 3. So I have 1 over R total to be equal to 2 plus 3 to give me 5 all over 12. Remember, I'm looking for R total, not 1 over R total, so I turn it back. I say R total over 1, then I'll now reciprocate this one. 12 divided by 5. And that's going to give me, it's going to give me 2.4 ohms. This circuit changes to something like this. So I have 2.4 ohms here, then I have 10 ohms here. And when resistors are connected in series, you simply add them. So I'm going to have R total to be equal to 2.4 ohms plus 10 ohms, and that will give me 12.4 ohms. Now that I've known the value of my resistor, I can calculate the current because V equals IR. I'm giving V to be equal to 12 equals I multiplied by my R is what I've gotten, 12.4. I'm looking out for I, so I divide both sides by 12.4, and I is going to give me 12 divided by 12.4. I is going to be 0.97. I remember to put the unit of current, which is amperes. This question is quite tricky. A galvanometer of internal resistance 50 ohms, so we're giving the internal resistance as 50 ohms, and full scale deflection of 20 milliamperes, so we're giving the current, which is 20 milliamperes, and it simply means 20 times 10 raised to the power minus 3, and that will give us 0.02 amperes. It's converted into a voltmeter by connecting a resistor of resistance. So we are given a resistance of 1950 ohms in series, and we're asked to calculate the maximum voltage in it. The maximum voltage is given by the sum of the internal resistance and the sum of the external resistance. So V is going to be 0.02 multiplied by 50 plus 0.02 multiplied by 1950. V is going to be 0.02 times 50 will give me 1, plus 0.02 multiplied by 1950 will give me 39. So 1 plus 39 is going to give me 40 volts. An electron moves the speed, so we are giving speed, which is 2 times 10 raised to the power 6 meter per second in a straight line. Calculate the wavelength. We are asked to find lambda, and we are given the mass to be 9.1 times 10 raised to the power minus 31 kg, and we are given Planck's constant has the symbol H to be 6.6 times 10 raised to the power minus 34 joules second. Now we have to use the relationship lambda equals H over mv, and lambda is going to be H is 6.6 times 10 raised to the power minus 34 all over m is 9.1 times 10 raised to the power minus 31 multiplied by v is 2 times 10 raised to the power 6. So lambda is going to be 6.6 times 10 raised to the power minus 34 all over 9.1 times 10 raised to the power minus 31 multiplied by 2 times 10 raised to the power 6 is going to give me 1.82 times 10 raised to the power minus 24. Then lambda is now going to be 6.6 divided by 1.82 is going to be 3.63 times 10 raised to the power 10 meters. I hope you get it. But to find the neutron-proton ratio in the nuclide represented below. So the nuclide is 7032. This is a number of proton, which is also called the atomic number, and this is the number of proton and neutron, which is also called the mass number. So for me to know the neutron number, I'm simply going to say 70 minus 32, and that will give me 38. So we have to find the neutron-proton ratio. So it's going to be 38, which is the neutron number, over 32, which is the proton number. So 38 divided by 32 is going to give me 1.18. Comment love if you got it. See you in the next class.